Hello everyone. Now this video focuses on how the earth wire and the fuse function together to keep our use of electricity safe. What we have in the circuit here is that it's connected correctly with the fuse, switch, the appliance and the earth wire. Now just to recap your memory, right, this L represents the live wire, and this is the fuse, this is the open switch, this is the metal casing, this is actually the load, right? It's usually denoted by the resistor symbol, but we call it a load. Okay, and this whole thing here is actually the appliance, and this is the earth wire. Right, N represent the neutral. Right, so I hope there's a recap here. Okay, so when the switch is open, as indicated by the open switch, there's actually no current. But how about when the switch is closed? Now when the switch is closed, the current flows from the live potential through the fuse, the closed switch, the load, and the neutral potential to the neutral potential. So in this way, this appliance, the one over here, the appliance will continue to function as it is supposed to be, right? And no problem here. This is supposed to be the correct connection, so there's no problem here. Now, but what if the live wire becomes disconnected from the appliance and now it touches the metal casing as indicated here? So right now, the live wire is now electrically connected to the metal casing. So that means when the switch is closed, the current flows from the live potential through the fuse, through the switch, through the metal casing, through the earth. And this is because current flows from higher potential to lower potential. So in this case, the live here is actually of a higher potential, and in this case, the earth is of lower potential. So the path which the current takes is of very low resistance. And since the potential difference between live potential and earth is about 240 volts, that means the resistance is also very low, and therefore from V equals IR, Ohm's law, the current will be very, very high. So this will cause the fuse to melt, as shown here, and hence disconnect the circuit from the mains. And when this happens, anyone who touches the metal casing will then avoid electrocution. So this is one example to show you how the fuse and the earth wire has to function together to keep the use of electricity safe. But having said that, bear in mind, although what I've drawn here about the earth wire is as if it's connected to the earth, but at home it's actually connected to your earth leakage circuit breaker. There's an earth leakage circuit breaker known as ELCB. This ELCB is found in a circuit breaker. You have to refer to your earlier notes as to how to locate the ELCB. So when the ELCB trips, it cuts off electrical supply entering the household. So other than the fuse melts, the current flow will actually trigger the ELCB to cut off electrical supply into the household, and hence that's when you get a blackout in the house. So basically, to summarize, your safety features do not function independently. Okay, they need to function together. Right? They need to function together to become effective in protecting you from electrical hazards.